In this video, we will solve something to do with similarity, congruence, and proof. Let's start off with this first problem where line segment JL is the altitude of triangle JKM. So, which statement explains whether JKM is a right triangle? Well, this 5 in the middle is irrelevant. That has nothing to do with it. So you should ignore that. If the large triangle here is a right triangle, then it should follow the Pythagorean theorem. Okay, you know, good old leg squared plus leg squared is equal to the hypotenuse squared. So, if this is a right triangle, then 13 squared plus 8 squared should equal the hypotenuse squared. Alright, so we could calculate this out. You know, this is 169 plus 64 is equal to hypotenuse squared. So that's 233 is equal to the hypotenuse squared. So of course, if I want to get h by itself unsquared, I need to take the square root of both sides. So round to the nearest tenth, the hypotenuse is 15.3. The hypotenuse, of course, is segment KM. So the length of KM is approximately 15.3. Okay. Alright, so I take it back. At the beginning I said we wouldn't need the 5. We will need the 5 because KM is approximately 15.3 if the big triangle is a right triangle. But we don't know if it is or if it isn't. So we need to figure out the length of KM in a different way. If it turns out to be 15.3, then it's a right triangle. If it turns out to be something else, then it's not a right triangle. So the way we can figure out what KM is by finding these two values. So I'm going to call this X, I'll call this Y. But you know, I think I'm going to change colors. So I'm going to find X right now. So we can do the Pythagorean theorem on this triangle right here, which is definitely a right triangle, and we can find X that way. So x squared plus 5 squared is equal to 13 squared. So x squared plus 25 is equal to 169. Subtracting 25 from both sides, x squared is equal to 144. Alright, take the square root of both sides. X is equal to 12. Okay, so x is 12. So now let's go back and find y. You know, I think I'll use this space. Alright, now I'm going to find y using this right triangle, which is definitely a right triangle. So y squared plus 5 squared should equal 8 squared. I'm just doing the Pythagorean theorem. Y squared plus 25 is equal to 64. Subtract 25 from both sides. Y squared is equal to, whoops, that's 39. And if we take the square root of both sides, y is approximately 6.2, round to the nearest tenth. So y is 6.2. If we add these together, alright, to find x plus y is equal to 18.2. Okay? So that should be the length of KM. That's the hypotenuse. Alright, so this is the length of KM. Alright, this is the actual length of KM. So if the large triangle was a right triangle, then it would have had a length of 15.3 because of the Pythagorean theorem. But we just found out that the actual length is 18.2. So that means it is not a right triangle. So we can throw out the top two choices that say that it is a right triangle. So it's not a right triangle because KM does not equal 15.3. This is the answer. All right, KM does equal 18.2. Okay, so there's your answer right there. Okay, so we have this transformation where the large triangle is ultimately mapped onto the smaller triangle. So which transformation could it be? Well, the size changed, the lengths changed. So so that means that there's some kind of a dilation happening, all right? Because that would change the size. So a reflection and a translation, neither one of these would change the size. So we can throw out that option. Okay, what else? This looks like there's definitely a dilation. All right, a dilation can be when the shape gets bigger or smaller. So so there's definitely a dilation. So the question is, other than getting smaller, did it do a reflection? Did it do a rotation? Or did it just slide over, a translation? So look at these markings. See how the markings are in the same position? All right, they're in the exact same position in both pictures. So that means it was not a reflection. All right, because then it would be backwards. All right, if it was reflection, then this picture would look more like this, with the, all right, they'd be facing each other. So it's not a reflection. It's not a rotation either, all right, because the position of the double marking didn't change. If this rotated or something like that, then maybe now it would be facing like this, okay, with something like this happening because of the way maybe it moved from the up to the sideways position. But nothing like that happened. All right, it's turned the same way, so no rotation happened. So all that must have happened is it slid over and shrank. So that's a translation and a dilation. So this has to be the answer. Okay, so these are similar, meaning the angles are all congruent. So what two transformations happen? So clearly there's a dilation because I went from a big triangle to a small triangle. So there's a size change. That means there's a dilation. But other than a dilation, is there a reflection? Is there a rotation? Or is there a translation? Okay, let me start from the bottom. A translation would mean that the image was just slid over from left to right. I mean, obviously it got smaller, but other than that. See how this point is sort of angling, pointing to the left, and this point is pointing to the right. So we didn't just slide it over, otherwise it would still be pointing in the same direction. So it's not a translation. Okay, what about a rotation? What about a rotation? It doesn't seem like it could be a rotation either. There's a clue in the order of the letters. They're telling you which letters are corresponding to each other. For example, see how Z is on the end and G is on the end. That tells you that these two are corresponding points. So the Z becomes the G. All right, they're mapped onto each other. So if this were a rotation, then this would move. So if I did a rotation in some kind of way, this point Z would move somewhere else, like maybe it would come down here or something. Okay, but point G is still in the same spot where it was. I mean, it's on the other side of the line, but it hasn't moved down or anything like that, or up. All right, it's just straight across. So that tells you that it's actually a reflection. Okay, and it's a big hint because they have this reflecting line right here. So Z was reflected to exactly the opposite side onto G. Y is reflected, all right, the same distance. Okay, well, you know, obviously it had to shrink first, and then it was reflected, you know, because of the dilation, and then the Y was reflected onto A. So reflection, there's a dilation and a reflection. You can see how they're facing in opposite directions. You see the reflecting line right here. Those are both huge hints that you're dealing with a reflection. Okay, triangle QRS is dilated using the rule right here. So this tells us that P is the center of dilation, which you can see in the diagram, but the 3/4 is the scale factor. So all of the lengths should be 3/4 what they are, and all of the distances from P should be 3/4 what they are. Okay, so focus on 3/4 being the scale factor. So what will be the distance from the center of dilation P to the image of S? Well, the current image is 8. Well, I mean, the original point S is a distance of 8. So the image should be 3/4 times 8. All right, just use the scale factor, and that will give you the new distance. Okay, so this will be S prime. It'll be some new distance that's 3/4 the original distance. Okay, if I were to multiply this out, this is like 8 over 1. 3 times 8 is 24. 4 times 1 is 4. 24 divided by 4 is 6. So the new distance would be 6. So this is the answer. All right, on this problem, we are given the median of a triangle. A median is just the connector of midpoints. And we know this is a midpoint because the markings are the same on both sides. This is a midpoint. You see how the markings are the same on both sides. When you have a median like this, it's always going to be half of the distance of the side that's sort of parallel. All right, the median is going to be half of this bigger side. So in other words, if I take the big side, 6p minus 4, and if I do half of that, half of the big side, it should equal the other side, 2p plus 3. Or I could say, if I start with the small side, 2p plus 3, if I double it, then it should equal the bigger side, 6p minus 4. I don't care which way you do it. So say if I do it this way, I'm doubling the small side, it should equal the big side. So a little distributive property tells you that this is going to be 4p plus 6 is equal to 6p minus 4. And then I'm going to subtract 4p from both sides. So that'll give me 6 is equal to 2p minus 4. Then I will add 4 to both sides. So 10 is equal to 2p. Divide both sides by 2. So p is equal to 5. So p is 5, but of course that's not the answer. They're asking what is length AQ. So AQ, let me change colors. AQ is right here. And we're told that AQ is 4p. So that means now that we know that P is 5, that's 4 times 5, which is 20. So this should be the answer right here. Alright, this next problem is tricky because there can be more than one right answer and we have to find them all. But what we know is if we have a line that's parallel to one of the sides, then it's creating similar triangles. So this triangle, this blue triangle, is going to be similar to this red triangle. Alright, the small triangle will be similar to the big triangle, which means that we have angles that are the same. Alright, the corresponding angles will be the same. Of course, these sides are parallel. And then we have all the things that are proportional. Okay, so I guess we'll just have to cross that bridge when we come to it. So which statements are true? Triangle BCD, okay, that's the red triangle, is similar to triangle BSR. That's the blue triangle. That's what we just said, so that's definitely true. Okay, now BR over RD. Okay, so BR, so that's like, I'll put an X right there, over RD, so that's like a Y. So we have X over Y is equal to BS over SC. Okay, and that's, I'll say, need more letters. Okay, R over M. So X over Y is equal to R over M. Okay, that's true. That's one of the little theorems that we know. If we have the parallel split, part over part equals part over part. That's true. Alright, next one looks tricky. If the ratio of BR to BD is 2/3. Okay, so BR, okay, to BD. Alright, so X over Y is equal to 2/3. Then it is possible that BS equals 6. Okay, BS would equal 6 now, and BC would equal 3. And BC would equal 3. Okay, so let's set up an equation and see. So the equation would be part over whole is equal to part over whole. So X over Y, that's part over whole, is equal to part over whole on the right hand side, which would be 6 over 3. Well, this doesn't even make sense because 6 is supposed to be the smaller length, and then the 3 is supposed to be the bigger length. So just visually that doesn't make sense. But of course 6 over 3 simplifies down to 2. So we have xy is equal to 2. But then we were already told that xy is supposed to be 2 over 3. So this is nonsense on many levels. So we can definitely throw that out. Okay, alright, what about this next one? BR times SC. Okay, I threw some letters on here just for reference, but BR, in fact, let me just recopy this. So they said BR times SC, and that's supposed to equal RD times BS. So RD times BS. Okay, so BR, that's X. Okay, and then SC, that's B. So we have XB is equal to, and then RD, where's that? RD, that's y, and BS, okay, that's A. Alright, so we have XB is equal to YA. So this doesn't really mean a lot to me in this form, but I see the X's and Y's and the A's and B's. What I'd like to do is get the X's and Y's together on the same side and get the Y's, the A and B on the same side. So one way that I could do that is imagine that if I divided both sides by Y, for example. Okay, so now I've got XB over Y is equal to A. And now imagine that I divide both sides by B. Okay, so that's going to give me X over Y is equal to A over B. Well, that makes plenty of sense. X over Y, so that's part over part is equal to part over part. Alright, everything in the same order. X over Y is equal to A over B. This is definitely a true statement. Okay, so that means the original statement must be true. You know what, I could have approached it the other way and it might have been better. Once we saw that the equation is involving x, y, and ab, we know that x over y should equal a over b. Okay, we know that. We could start with that. And then we could cross multiply. And if we cross multiply, then we wind up multiplying x times b and y times a. So that would give us xb is equal to ya. Alright, and that's what this is. xb is equal to ya. So this is definitely true. Okay, so we'll check that one off. Alright, last one. Alright, so I just recopied it. BR over RS is equal to BS over SC. Using the letters that I've written, this becomes X over M is equal to A over B. So let's see if this makes sense. Okay, let's start with the A over B because it's the most clear. So A and B, that's part over part. So part over part should equal part over part. So A over B should equal X over Y. But look what they did. They have A over B is equal to X over M? What? That's crazy. It shouldn't be M. That should have been Y instead. That would have made sense. But the way they have it, it doesn't make sense. So that's definitely wrong. Okay, in parallelogram blah, WY is equal to 12. Okay, so they're telling us that WY is equal to 12. That's this entire length. Which immediately tells us that each of these pieces will be 6. Because in a parallelogram, the diagonals bisect each other. They cut each other in half. Okay, and then we have XZ is equal to 16. Alright, so again, if XZ is 16, then we know that each one of these pieces is 8. Alright, now WX is 10. Alright, so this is 10. And XY is equal to 9. XY is equal to 9. What is the length of segment MX? Well, we already said that MX would be 8 because it's half of the total thing. So could it really be that easy? I guess it was.